Hello everyone, I'm HJYoo from KAIST. From today, the second international running robot competition starts. And I'm very happy to have this chance to introduce you about semiconductor IC and AI robots. The AI robot contains many semiconductors inside. For example, the AI chip, MPU or CPU, are required to control and also make intelligent decision. And there are many sensor chips to give a feeling to the robots. For example, touch sensor or image sensor. And also it needs many actuator chips to manipulate its body, like arm control or leg control. And also on top of those simple functions, many complicated functions are necessary for the semiconductors to provide to the AI robots. For example, human-robot interaction is necessary to communicate with users through voice user interface or user recognition or intention recognition. And also more complicated intelligent functions like knowledge representation or knowledge training are required. And wireless and wireline network and software architectures are necessary, including the middleware and embedded OS and many AI robot application softwares. Those semiconductors play so important important role in AI robot. Then how we can develop the AI semiconductors? The semiconductors play so important role in AI robots. Then how you can develop your own AI SoC or your own AI semiconductors? The most important part is your imagination and dream. If you have a nice idea to make your own robot behavior or robot functions, then develop your own software. And then, based on your own software solution, you can develop the system using the PC. And then your software is converted into the SoC design. And then if you complete your conversion or your design, then send it to the semiconductor manufacturing company, like SMIC or Samsung. And then they fabricate your own SoC. So it's very simple, right? So the most important part is your dream and your imagination. And if you have a clear and good imagination and dream, then just develop your own semiconductor and your own system. Back in the 60s and 70s, when I was an elementary school student, life is very simple. If you want to develop the audio amplifier, you just buy about few transistors, for example, 8 transistors and 8 capacitors and some resistors, and then you assemble it. Then you can develop your own audio amplifier. It was very easy to realize your hardware dream. But today, hardware becomes so complicated. For example, the Intel Xeon E5 V4 contains 7.2 giga transistors inside. It's too complicated, so one person cannot handle it. So because of such hardware complexity, circuit designers lose system dreams. And perhaps most of you never ever think you can develop your own hardware or your own semiconductor. But you can do it. VLSI, we think about the evolution of the if we think about the evolution of the semiconductor, okay, let's think about the evolution of semiconductor. Transistor was invented in 1948, and then it was evolved into the IC integrated circuit, and IC was evolved into VLSI, and VLSI was evolved into the SoC. And the previous invention, the transistor, is just a component of the next invention of IC, and IC is just a component of the next invention, VLSI, and VLSI is a component of the SoC. And the current system is based on the SoC. So if you disassemble the current system, you can find it's just a combination of the SoC. So the famous future theorist, Ray Kurzweil, said the evolution uses positive feedback. That means all the previous inventions is the base of the next invention. And recently, hardware is evolved, and recently there are many fantastic hardwares like a smartphone, wearable computers, drone, robot, and all of them are just a hardware. So it's sort of hardware renaissance. Previously, most of industries focused on the software because software is very easy to develop. But lately, they come back to the hardware due to the maker movement. Maker movement is a do-it-yourself movement. So she is a computer engineering major, so she didn't have any hardware education, but still she founded hardware company, Little Bits, and it was very successful. So those hardware systems are based on the semiconductor. So it is possible for the hardware renaissance because of the semiconductor or semiconductorization. So how we can develop the semiconductor, even though it is very complicated recently. You can use the Lego-like development. So you can develop small component. It's just a Lego block, and then it has a standard interface, and then you just assemble it. So by assembling small components, you can build a big system, or semiconductorization is possible. So with this method, you can easily realize your dream and imagination, especially hardware dream and hardware imagination. More technically, we called it a platform-based design. So we prepare the platform. Platform is a Lego board, and then it has a standard IP protocol. So if your component just follow the standard interface protocol, you can just assemble it very easily like a Lego assemble. So the functional block or semiconductor IPs are assembled as a complicated SoC. So it's very easy. You can easily design a very complicated SoC just following the Lego-like development process. Okay, let's go back to the robot. The running robot is the name of we called it, we emphasized SoC. We emphasize the SoC because the most important parts of the robot is the SoCs. An intelligent SoC robot is the combination of the AI software and semiconductor IC and robot applications. And the SoCs are integrated on a board, and it contains the AI software to provide robot application to the robot body. And the robot body usually takes the form of the humanoid, and it performs the mission or the combat to each other. The previous SoC platform used in Korea was a tank platform. So it looks like a tank. And it uses a very large board. And it has a laser gun and 10 LEDs and many sensors around the body and a collar hat. Okay, next, we changed the platform from the tank to the humanoid. Every year, we held the AI SoC robot competition, and from 2002 to 2018. And every year, more than 100 teams have participated in the Intelligent SoC Robot War, or AI SoC Robot War. So this is the one example. So the robot is autonomous, of course. And if you hit the other robot and it's fall down, then you win. Okay, so AI SoC robot is the combination of the AI software and semiconductor IC and robot application. So the software is integrated on the flash RAM, and SoC, or the chip, is implemented as through the FPGA. AI SoC robot is the combination of the AI software and a semiconductor chip and robot applications. And the semiconductor chip is realized with the FPGA. FPGA is a programmable gate array, and you can easily change it. Its function robot is the combination of the AI software and semiconductor IC and robot applications. And semiconductor IC is realized with FPGA. With FPGA, you can easily develop the CPU or DSP or NPU. And AI software is stored on a flash RAM. And later, those chips are integrated on a board and installed inside the robot to provide the robot applications. So more detail of the AI SoC robot. The SoC is the combination of the software and chip, and the software is the combination of the many hierarchies, application layer, and middleware, and kernel, and monitor layer. The application layer is composed of control and strategy programs, and middleware is libraries and application tasks, and kernels are operation system and system management. And AI SoC has functions, hardware functions of image processing and voice recognition, and wired and wireless communication with many memories. To control the robot body, which has IR sensor and motor and bottom sensor and battery monitor and display. For example, to optimize the software for the successful AI robot, how to optimize the software for the AI robot. It should be well matched with SoC. For example, you should develop the AI, but there are many bottlenecks for the realization of the AI, because your CPU and your memory size are very limited. So there is some limitation in memory bandwidth, and also power consumption should be minimized. So you should develop your software and SoC to increase the memory bandwidth and reduce power consumption. So the SoC is very important to optimize the software. So you have to understand the SoC very well to program very nice software. So the optimized software together with the SoC is the key to win the robot war. So the strategy is very important. And of course, the code should be optimized for the small size of the memory and very limited computation power of the CPU. Well-optimized software provide very powerful robot behavior, so you can win the competition. In some sense, brain is most important to win the robot competition. If you cannot develop the very successful software, you may lose. And if your brain software is very powerful, then you can win. So robot brain is nothing but the semiconductor chip. So the semiconductor chip is the most important part of your AI SoC robot, or your running robot. So let me introduce you some examples of how to develop a very nice semiconductor chip. Our team developed new AR glasses, and AR glasses doesn't have any interface system. So you have to shout, "Okay, glass, take a picture." So voice interface is only the way you can put the input to the glasses, or you have to touch your glasses. So people around you know what you are doing. Because you are shouting, or you use your hands to input some command to your glasses. So instead of voice or touch, if you can use your gaze as an interface, then nobody knows what you are doing. So we try to develop the iMouse. iMouse is composed of just the glasses. And if you stare at on one object for a long time, about 10 seconds, longer than 10 seconds, then the cursor appears. And if you change your eyeball, you move your eyeball, then the cursor moves. And if you wink, then the cursor is clicked, so you can select the target object. So it's just a mouse, but the operation is done by your eye movement. It's very convenient, and you can conceal what you are doing from people around you. So we developed two chips. One is the functional CMOS image sensor to detect the gaze, where you see and how long you watch it. And another chip is an object recognition processor. And the object recognition processor has many functional blocks inside. And its size is 4 millimeter by 4 millimeter. And real-time object recognition is possible. But in order to reduce the power consumption, we have developed a special, in order to reduce power consumption, because it is a mouse, so we have to reduce the power consumption. So we reduce the object recognition processor power down to the 65 milliwatt, and the gauge image sensor power is less than 10 milliwatt. We developed this system. We developed a common system platform. It has a CPU with DRAM and the analog front end, and camera front end, and stereo display for the AR, augmented reality glasses. And we developed our chip, a gauge image sensor, and object recognition processor. And we developed FPGA glue logic to connect our chip to the common system platform. And this is the picture of our eyeglasses. And this is two glasses show you the stereo, and this is the gauge image sensor to detect your gaze direction and your gaze location and gaze direction. This is the gauge image sensor to detect and locate your eyesight. And we use the this is the gauge image sensor, and IR LEDs shine the IR light to your eyes, and then gauge image sensor detect the your iris and your gaze sight. And this is the glasses frame, and that part is just on your nose. And there we put the electrode to detect your wink. So this electrode can detect the wink or the click of the eye mouse. Let me show you the demo video. So as you move your eyesight, the cursor moves. and you can select, and then you can check through the web without any hand movement. And if you inside the cafe and see other people, and if you find very nice items like clothes or shoes, then you can easily check its price through the web. And another example is DMPU. DMPU is composed of two deep learning processors. One is a CNN. CNN is very famous for the visual picture extraction for the static image. And RNN is very famous for the sequential data recognition. So if you combine the CNN and RNN together, then you can recognize the gesture of the gesture or the action. So this is the hand sign and sign language, and the meaning is look around. So we integrated CNN and RNN together on a single chip, and also other peripheral circuits. And this chip was developed using the platform-based design approach. So it's just a Lego block assembling. And this is a chip photo. And it's fabricated with 65 nanometer 1P and 8M CMOS technology. And its power consumption is 34.6 milliwatt at 0.77 volt, and 280 millivolt at 1.1 volt. And this is the demo video. And it is assembled as a board and installed inside a robot. Wake up. And it recognizes the speech. And recognize the object. Follow me. So it's action and voice recognition. Yeah. Show me your memo trainer. Follow me. Bye-bye. Okay, so in this presentation, I told you you should have your own dream, especially system dream, a hardware dream. And you should be the system designer. So you can develop your own system. You can design your own system. You can develop your own system. In this presentation, I told you you have your dream, your own dream about the system and hardware. And you can be a system designer. You can design your own semiconductor. So you should design your own semiconductor, and semiconductor design is nothing but the assembling the IPs. So semiconductorization is the way you should develop. Semiconductorization is the way to develop the system, and you can develop your own system. And also, I explained robot system is nothing but semiconductor chips in a moving box. So if your computer has legs or wheels, then it's a robot. And of course, most important part is the semiconductor. So semiconductor is the key of the robot. So you can realize your dream with a semiconductor chip design.